Assalamu alaikum guys, and how are you guys doing? So we have a question which is state transition counter. Okay, this is the state diagram which I was given by, and it starts from 2, goes to 5, 1, 4, 7, 0, back to 2. And if the counter has 6, it will go directly to 2. And when the counter is at 3, it will go directly to 2. Now, how to formulate our counter from this? We have some few steps. The first step is to construct what we call as excitation table. Excitation table is like a table that will guide you to write this table, this big table, which you will use it for creating the circuit itself. Now, how to write this excitation table? You start with writing Q present, Q next, and the flip-flop that you're going to use, which is either T, J, K, or whatever, okay? So Q present, meaning that it is the output that is at the present state, and Q next, meaning the output that will change after some time, okay? So you write as it is, as what we do in our class in truth table, the inputs 0 0 1 1, and then the next one 0 1 0 1 normally. Now you check 0 in the present, it changes to 0, meaning it didn't change anything. What will be the T in the truth table? Okay, in the truth table the T will be 0. Okay, if you remember T flip-flop, when it is 0, the output doesn't change. When it becomes 1, the output changes in the opposite signal. Okay, so we go to next one. Q present is 0, Q next is 1, meaning from before, in the present, okay, the output is 0 and then it changed to 1. So from this, what we know, we write T as 1 because it changed it from 0 signal to 1 signal. Okay, we continue. Q present is 1, Q next is 0. Same process. So it changed from 1 to 0. Okay, so it means T is 1. Yes, the next one is Q present 1, Q next 1, meaning it didn't change. Okay, so here T will be 0. Now you have your excitation table, no problem. Okay, now we move on to the next table. As before, you write your present state, your next state. Now, because the numbers here, okay, when you present in binary, it becomes 3 bits, meaning 0 0 0. Okay, 3 bits binary numbers system. Okay, so for that it means we have 3 outputs for every flip-flop. Okay, you have 3 flip-flop, you have 3 outputs. You take those outputs, you put it here for the present state and for the next state. Okay, now in the present state you write as what we write in the truth table. Okay, in the inputs 0 0 0 0 4 1 1 1 1 4 0 0 1 1 2 2 0 0 1 1 2 2, and then the next one is 0 1 0 1 0 1 0 1 until the end. Okay, now for the next step, for the next state, okay, we look from this to this. Okay, like let's say for example the first one 0 0 0 0 0 0 in decimal form is 0 in short. Okay, we take this, we put it here in our state diagram. Where is our 0 in this diagram? This is our 0. Okay, the 0 next to it, okay, the one that goes next to it is 2. So the next state for this 0 0 0 is 2. We take this 2, we change it to binary system, which is 0 1 0. Next 0 0 1. 0 0 1 in decimal is 1. So we check where is our 1 here. This is our 1. 1 after it is 4. So the next state will be 4. So you write it in binary number, which is 100. So you go on like that until the end, which is 7. Okay, 7 here. The next one is 0. So you write 000. And when you reach 6 and 3, as I said, 6 and 3, they will all go to 2. So like, let's say, for example, if we see our 3 here, 0, 1, 1, okay, this is 3, it goes to 2. So you just write 2, 0, 1, 0, okay? This is our 6, okay? It goes to 2 again. So you write 0, 1, 0, no problem. Now, after writing this whole, you write your T flip-flop. Remember, you're using 3 T flip-flop for 3 outputs, okay? So, you have T0, you have T1, you have T2. Now, from this excitation, you can write your T's. Meaning what? Okay, we'll start with T0. T0, it has the output of Q0, respectively, okay? T1, Q1, T2, Q2, okay? Now, we check. T0 for the first column, okay? For the first column. Q0, how it changes in the next state, okay? Here, 0 changes to 0, so there's no change at all. So in our excitation, 0 to 0, our T should be 0. So you write 0. Okay, we go to the next one. You find what is your Q0. Q0 is 1. Your next state, it is 0. So it changed from 1 to 0. In our excitation state, 0 to 1, it is 1. So you write 1. Okay? The next one, again, you check your Q0, present and next state. 0 to 1. You check again. 0 to 1, the T should be 1. So you write 1. Then you go the same process with T0. T1, same process. Okay, you check your Q1 in present state, your Q1 in next state. And then you check. 0, present state, it changed to 1. 0 to 1, your T should be 1. 1. Okay? Same process for T1 and same process for T2. Okay, no problem. Now, in order for any kind of truth table, in order to make it into a circuit, okay, you need to take either SOP or POS. But in our case, SOP for us, it will be a bit longer, okay, because you have 3 outputs. So you have 3 elements inside of one term, okay. So to make it easier, we have this K-map, okay. K-map, originally, you use inputs and outputs. So now, K-map, we use K-map for inputs and outputs. But now, the system changes. It doesn't change that much, okay. We have our gray code, 00011110, and here 01, no problem. But the inputs now, we take them as the outputs, okay, of our present state. Alright. So let's say if we want to take 000, this is 000, okay, 010. This is our 010, okay, 001, 001. So it means this, so it means 000 is this box, 001, this box, and so on. Alright. Now, you start with 000 or any of the boxes, okay. 000 is this box. We check here, we check our T table, okay, because in the K map we actually check the output, but here we check the T table, okay. 000, 000, this is the first row. So you check what is your T. T is 0. And by the way, you have 3 t's, so it means you have to write it 3 times. So for here we're concentrating on t0. Okay, so 0 0 0, first row, you check what is your t0. It is 0, you put 0. 0 0 1, this box, you check 0 0 1, this is your row, you check what is your t is 1, you put 1. 0 1 0, this is the box. 0 1 0 is this row, so you check your t is 1, you put your 1 here. And then you continue like that. 0 0 1 1 1 0 1 1 1 1 0 0 1 0 1, you finish. Now you start grouping all of them with ones. 1 1 1, so 3 groups. Okay, then after that we formulate our formula. Okay, we do the same procedures. Okay, like for example this group, you cancel the 0 with the 1, so it's only q2 0, q2 0 meaning q bar. Okay, and this is just 1, so q0 without bar, plus the second group. This is the second group, this cancels with this, so you have 0 1 meaning q2 bar and q1, which is this one. Okay, the third group, okay, this one cancels with this one, so q1 q0. All right, you do the same procedure as t1 and t2. Okay, the same as what we did before. 0 0 1, this box you check. 0 0 1, okay, this is t1, so t1 has 1, so you put 1 here, and you can continue yourself. Now the same process again with the grouping. You group the ones, you write your equation, no problem. t2, same thing, group them, put the t's, group them, you write your equation. Now after you get all of your equations, okay, this is our t0, okay, t0 t1 t2, then you write your flip-flop. Okay, starting with the clock. The clock signal all is connected to the 3 flip-flops. This is first step. Second step, you just write your t0 q0 q0 bar, t1 q1 q1 bar, t2 q2 and q2 bar. Okay, and then you start to formulate your counter. Now for t0 has this kind of equation. Okay, if you see it clearly, here is q2 bar, here is q0 plus q2 bar q1 plus q1 q0. Okay, we start with the first one. t0 has q2 bar q0 without bar. They are times together meaning it's AND gate. Okay, now you find your q2 bar, okay, and your q0. You take these two, you put them together, you put them in the AND, no problem. q2 bar q1, q2 bar, okay, q1, this is your q1, this is your q2 bar. I took it from the previous one. Okay, put them in AND, no problem. Same one with this, q1 q0, you check your q1, this is q1, and q0, this is your q0. So in my diagram from here I took q0 and I took q1. Okay, put them in AND, and because between them there's plus, so it means the output of these should be put inside OR gate. Okay, that's what I did here. I took all of the 3, I put them in OR. Now the output of this OR, okay, it goes to the t0. So you take this output, you input in the t0. t1, same process. Okay, this is your t1 from here. So I took these signals. Okay, this is q0, Q1 bar, and I have Q2. Okay, which is this Q2, Q1 bar, Q0 bar. Okay, this one, second one, I have Q0, I have Q2 bar. Okay, Q2 bar, Q0 bar. Okay, this one I have Q1 and Q2 and yeah, Q0, which is this Q2, Q1, Q0. All of these output are put in the OR because of the plus, and then to the T1. Same thing with T2. T2 is this one. Okay, the ends, the outputs, which are the inputs, which are these ones. Done. So this is how you create counter by using T flip-flop.